about equivalent ratios. You've heard the word equivalent before when we talk about equivalent fractions, and they're very similar. So if you remember the word equivalent, it means equal. Okay, so we're going to be looking to see if two ratios are equal to each other and what that means. And to do that, we're going to look at some word problems. We're going to look at some graphs, so coordinate planes, and we're going to look at some tables of information. Okay, so we're going to go through the first two problems together. There are two different ways to determine if a ratio is equivalent. I'm going to show you both ways, and then you'll determine which way works best for you. So our first example is 20 miles in 5 hours. So is that equivalent to 45 miles in 9 hours? So we're going to take the first part of the problem and set it up as a fraction. So 20 miles, 5 hours. Put an equal sign. 45 miles, and then a fraction bar, 9 hours. So there's two different ways to determine if these ratios are equivalent. So the first way is we can find the unit rate of each one of these. So the unit rate of 20 over 5 is 4. The unit rate of 45 over 9 is 5. That would mean that these ratios are not equivalent because the unit rates do not match. However, there's another way, and the way that I prefer, to determine if ratios are equivalent, and that's called cross-multiplying. So the first thing that you're going to do is you're going to do 45 times 5, and you're just going to go across just like that. And if you take your calculator, you're going to get that that is equal to 225. Then you're going to go the other way, 9 times 20. And you're going to get that that is 180. Because these two numbers do not match, these ratios are not equivalent. So the answer is no. All right, let's look at our second example. In our second example, you're going to see right away that we have money. We're dealing with dollars or cents. And if you remember back from unit rates, the rule with dollars still applies. They always go on top of the ratio. So here we have 3 t-shirts for $21 or 5 t-shirts for $35. So we're going to set these up as a fraction. So we're going to have $21 over 3 shirts equals $35 over 5 t-shirts. I'm going to show you again the two different ways to determine if they are equivalent ratios. So let's take the unit rate of 21 over 3. So if you put in your calculator 21 divided by 3, you're going to get 7. If you put in your calculator 35 divided by 5, you're also going to get 7. That's 2 big thumbs up that these are equivalent ratios. However, I'm also going to show you the other way. If you multiply across and you do 3 times 35, you're going to get an answer of 105. And if you go the other way, 5 times 21, you're also going to get an answer of 105. So that's your second check to make sure that they are equivalent ratios. All right, let's look at a couple other problems here. So it says Felicia has read the first 60 pages of a book in 3 days. She read the last 90 pages in 6 days. Are these ratios equivalent? And we need to go ahead and explain our reasoning. So first, let's set up our ratios. So we have 60 over 3, and that comes from 60 pages over 3 days. We put our equal sign, and then we have 90 pages over 6 days. Okay? Now, I'm going to cross multiply from here on out because that's the method that I prefer to use, but you are more than welcome to simply find the unit rates and do it that way. So I'm going to cross multiply, and if I do 3 times 90, I'm going to get 270. And if I do 6 times 60, I'm going to get 360. So the answer to this is no. They are not equivalent rates. They are not equivalent ratios. And the reason why is because Felicia reads at different speeds for each ratio. And if we want to get even more specific, you could find then the unit rate here. 60 divided by 3 is going to be 20. That means here that she reads 20 pages per 1 day. And if you find the unit rate here, she's going to read 15 pages per 1 day. So in the beginning, she actually read quicker. Okay? So let's take a look at example number 4. We have 3 free throws for 7 attempts, and we have 9 free throws for 14 attempts. So go ahead and set up your ratio. So we have 3 over 7 equals 9 over 14. And again, use whichever method you prefer. I like to cross multiply. So 7 times 9 is going to be 63. And then we're going to have 14 times 3, which is 42. So the answer to this is no, they are not equivalent. And if we're asked again to explain our reasoning, why are they not equivalent? Well, the free throws the free throws are made at different rates. Okay? All right, let's look at another example. Again, we have this one involving money. We know money always goes on top. So Selena's comparing the cost of 2 packages of DVDs. One package has 6 DVDs for $90. The other package has 3 DVDs for $45. Are they equivalent and why? So go ahead and we're going to set up our ratio. Our first one is $90 over 6 DVDs. Set our equal sign. The second one is $45 over 3 DVDs. Again, use whichever method you want. I like to cross multiply. So 3 times 90 is 270. And then 6 times 45 is also 270. So yes, these are equivalent ratios. Now we need to explain our reasoning. This means Selena pays the same price per DVD. And to check that out, all you would have to do is find the unit rate of each one. So for the first fraction over here, 90 divided by 6, it's going to be $15 per DVD. If you find the unit rate over here, it is also $15 per DVD. Okay, so you try these 3 examples. Remember, money always goes on top. Go ahead, determine if they're equivalent, and explain why or why not. Okay, so go ahead and check your answers. Pause the video if you're not done yet. So for the first one, you should get no, they are not equivalent, so they are different prices per bagel. For the second one, you should get yes, they are equivalent because you're paying the same price per book at both places. And for the third one, yes, they are equivalent because you're getting the same amount of money per hour that you work. Okay, so now that we have that, let's just do two more, and then we're going to go into some coordinate planes. So we have 12 minutes with 30 laps, and we have 48 minutes with 120 laps. Set up your fraction or your ratio. 12 over 30 equals 48 over 120. And this problem here is just asking us to solve. So we have 30 times 48, which is going to be 1,440. And then we have 120 times 12, which is also 1,440. So yes, these ratios are equivalent. All right, let's look at this last one here. Jenny's comparing the cost of two packages of socks. One package has 8 pairs for $12. The other package has 3 pairs for $6. Are they equivalent? And let's explain our reasoning. Dollars always go on top. So we have $12 over 8 pairs equals $6 over 3 pairs. I like to cross multiply, but you can also find the unit rate. 8 times 6 is going to be 48, and 3 times 12 is going to be 36. So no, these ratios are not equivalent, and the reason why is because they are a different price per pair of socks. And you could take it a step further and find the unit rate to determine how much each pair of sock costs. And just to do that one more time, I'll show you. So for the first package, you would put into your calculator 12 divided by 8, and that's going to give you $1.50. For the second one, $6 over 3 pairs, that's going to give you $2. So it's actually cheaper to buy the pack of 8 for $12. Okay, we're going to keep with equivalent ratios, but we're going to look at it in the context of coordinate planes. So here we have Nivy collects 12 new coins each year. Use equivalent ratios to graph the growth of his collection over time. So here, the part of the chart is already set up for us. We have 12 coins in 1 year. So how do we make this next an equivalent ratio? Well, we went from 1 to 2, so we doubled 1, so we have to double 12. So 12 doubled is 24. You can think of them as equivalent fractions if you put a little fraction bar here, okay? So how do we get from 1 to 3? Well, we triple it. So triple 12 and you will get 36. How do we get from 1 to 4? Quadruple it. So you're going to quadruple 12 and you're going to get 48. How do we get from 1 to 5? We multiply times 5. So 12 times 5 is going to be 60. Now we need to go ahead and put these on the coordinate plane. Let me scroll up just a little bit, okay? The first thing that I want you to do, though, is to label your axis. So your y-axis is coins, and your x-axis is going to be years, okay? So our x is 1, our y is 12. So I go 1 and then up 12. The next one, the x is 2, the y is 24. x2, y 24. The next one is x3, y 36. The next one is x4, y 48. The next one is x5, y 60. And that's all the data that we have from the graph. But based on the lines, we could see how the trend would continue. This should also look a little bit familiar as a linear equation. And my line is not very straight, but you understand where it's going. Okay, we have a question now based on the graph. If Nivy continues to collect coins at this rate, use the graph to determine how many coins he will have after 8 years. So, I'm going to change colors here. After the 5th year, he'll go up to the 6th year, the 7th year, and then the 8th year. So after 8 years, how many coins will he have? He will have 96 coins. All right, let's look at another example. So here we have Adina. Adina walks at a rate of 3 miles per hour, and that per hour means 1 hour. Complete the table using equivalent ratios. So here it has started to set it up for us, but we're missing a lot more numbers. So she walks 3 miles in how many hours? Go back to the word problem, in 1 hour. Now if I look at how the pattern of this bottom row is going, it is 1 space 3 space 5. You can assume that it's going to go 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. And now based on this, we need to go ahead and, complete our equivalent ratios. So if she walks 3 miles in 1 hour, we double to 2, the miles will double to 6. If we double to 3 hours, then the miles, if we triple to 3 hours, then the miles triple to 9 hours. If we multiply times 5 hours, then we multiply the 3 times 5 and we get 15 miles. Again, we're going to take this information and put it on our graph. The y-axis is miles, and the x-axis is hours. And I'm going to fit it in over here. So let's go ahead and graph the points. We have our x is 1 and our y is 3. So 1 up 3. Our next x is 2 and then the y is 6. Then we have an x of 3, a y of 9. We have an x of 4, a y of 12. We have an x of 5 and a y of 15. And again, you should have something that looks very much like a linear equation. If we look at our question, it's going to ask us about our graph again. So, what does the point 2, 6 represent? Well, the 2 is the x, the 6 is the y. So go to your graph. 2 up 6. What does this mean? Well, the 2 is on the hours, so in 2 hours, she walks 6 miles. Again, in 2 hours, she walks 6 miles. All right, next example. Bethany and Tiffany make bracelets with 8 charms on each one. So we're going to go ahead and fill in the chart. So it told us that there are 8 charms on one bracelet. So we know that for one bracelet, we have 8 charms. If we double to 2 bracelets, we need to double the charms. So we'll have 16. We need to complete the rest of our table. So we'll do 3 bracelets, 4 bracelets, and 5 bracelets. So at 3 bracelets, we need to triple it. 8 times 3 is 24. At 4 bracelets, we need to quadruple it. So 8 times 4 is 32. At 5 bracelets, we need to multiply times 5. 8 times 5 is 40. And now we need to put our results on the coordinate plane here. So we have charms are the y-axis. Bracelets are the x-axis. It's always important to label your axis. All right, so we have 1x and 8y. Then we have 2x, 16y, 3x, 24y, 4x, 32y, and 5x, 40y. Again, you're going to get something that looks a lot like a linear equation. Now, we have 2 questions for the information in our graph. What does the point 1, 8 represent? Well, 1 is our x, 8 is our y. So let's find it. 1, 8. Circle it on the graph. That means for every 1 bracelet, there are 8 charms. Okay, so for every 1 bracelet, there are 8 charms. All right, now our next question is, how many charms do they need to make 7 bracelets? So let's go back up to our graph. So if we continue our trend, that's 5 bracelets, 6 bracelets, 7 bracelets, 8 bracelets, and I can keep going, but I'm just looking right here for 7 bracelets, and if I look across, that's going to tell me I need a total of 56 charms. Okay, we have one more coordinate plane example. So this time we're actually going to work backwards. We're going to have the information on the coordinate plane, but we need to put it into the table. So it says we have number of bars and number of boxes, and it looks like we're talking about granola bars from the title of the graph. So our first coordinate is 1x, 10y. So this must be our x, this must be our y. 1x, 10y. If I look at the graph, 2x, 20y. The next one, 3x, 30y. The next one, 4x, 40y. And the last one will be 5x, 50y. All right, so again, we have 2 questions. What is the unit rate granola bars per box? So how many granola bars per box? That means 1 box. Well, we could use our graph or we could use the table. If we're looking for 1 box, we have that information right here. How many granola bars are in 1 box? There are 10 bars per box. You could have also used the graph to find that answer. You find 1 box, you go up, how many bars? 10. Okay, the last question, how many boxes do you need to buy in order to get 90 bars? Now that's a pretty easy number because these are pretty easy numbers to deal with in this example. But if you had more difficult numbers where the trend was not as clear, again, you could use your equivalent ratios up here and you can also use the graph. So we're looking for 90 bars, so we need to get right here somewhere on this line. So let's continue our graph. Here, 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 and there we go. We hit the line. How many boxes? 9 boxes. Okay, 2 last questions and then we're done with this lesson. So remember, equivalent ratios, they cover a lot of different pieces of data. So a graph shows the distance that a car traveled over time. The x-axis represents the time in hours and the y-axis represents the distance in miles. The graph contains the point 3, 165. What does this point mean? I have a hint here that you can make yourself a table. However, you can also make yourself a coordinate plane. So I'm going to make the table first. So it says that my x is, I have my x and my y. My x is hours. And my y is miles. And my point is 3, 165. We know it goes x, y. So this is going to be x, this is y. So what does this information show? Well, it shows in 3 hours you drove 165 miles. So which answer choice on there would you select? I'm about to tell you the answer, so pause if you haven't figured it out yet, but the answer would be C. They traveled 165 miles in 3 hours. Okay, let's try one more. Kina charges $11 per hour to babysit. She makes a graph comparing the amount she charges, which is the y coordinate, so she charges, and the time she babysits, which is the x coordinate, which is not on the graph. So again, you can make yourself a graph or you can make yourself a table. So I'm going to make a table. We're going to have x and y. And it says that the x coordinate is the time and the y coordinate is the amount she charges. So I'm just going to put the money here. Okay, so let's kind of work, we can work with the answer choices or we can work starting from time. So if she works 1 hour, how much money would she earn? Well, per hour, 1 hour, she earns $11. Okay, what if she works 2 hours? Well, we doubled that, so we have to double this, 22. Okay, what about 3 hours? You guessed it, 33. What about 4 hours? 44. What about 5 hours? 55. And on and on and on and on and on. Let's look at our choices. Is 3 on the x and 33 on the y on our graph? 3 on the x, 33 on the y. This checks out. What about 11 on the x, 1 on the y? Well, we don't have an 11 on the x. We have a 1 on the x, so this one does not check out. 5 on the x and 55 on the y. We're good with that one. 2 on the x, 22 on the y. We're good with that one. So which one of these is not possible? That would be B. All right, this is the end of a very lengthy equivalent ratios lesson. I hope that everything was crystal clear. If not, rewind, fast forward, pause, rewatch, and as always, ask me any questions in class.